So far in Haskell, we've seen basic monads. We've seen things like maybe and either, which we use to simulate error handling in a way that Haskell might not otherwise support. Now remember, Haskell is referentially transparent and it's pure. What that means is we can't do things like mutate state, because once something's been assigned a value, it has to keep that value forevermore. And the same with functions. When you supply a function with input, it has to return the same output, because that is the same as trying to mutate state. If you tried to give back different things for the same input, Haskell will be upset with you. So we have to worry about things like this. Now, so how would we do something like, say, input, output? And that's what we're going to look at today. Well, to do input, output, we might want to return different values. So we would evaluate referential transparency. And we would need side effects, which we also can't do in Haskell without the use of monads. And that's what monads allow us to do. So today we're going to have a look at the input-output monad that wraps all of the actions that we would carry out in an input-output environment in a monad, and allows us to do things that might otherwise not be happy, Haskell might not be happy about. So for example, a main method could do weird things. It could return different values for the same input. It could do something else odd that Haskell might not like, but the IO monad will let us do that. So we're going to write a main method today, and all we're going to do is convert a string to an integer. So I've got a couple of functions here that are going to let me do that. So let's start by declaring a main method. Haskell, just like any other language, will have a main method. And then we want a do condition, because we're in a monadic environment here. We're in the IO monad. So we need do to chain those computations together for us. We could use bind, but that would be a bit more cumbersome. So what I'm going to say is we should put a string to the user, print this to the terminal just so they can see what they should do. And we're going to say enter string. And then I'm going to do the usual tidy or neatness of input output, where I do a /n so that it looks a little bit less cluttered. And then we're going to get something from the user. So I'm going to say string, and this is going to come from get line. Now that just gets a line from the user up until they hit enter. Now, one thing that's worth pointing out, I said in the do notation video that this arrow is allowing us to bind this to a local variable, so we have a value that we can work with, a name that we can work with. And while that's true, it's also doing something a little bit more. So what is it doing? Well, if we come down here and we say get line, this doesn't have the type string, it has the type IO string, so it's a monadic value. However, if I want to apply this function, I want to work with a string. This is not an IO string function. This is just a basic pure function. So what this arrow is also doing is allowing me to work with the value that's under the monad value. So we'll see this working if I do put string, because this value function check string evaluates to a string, so I want to return that. So let's say we check string on string, and then let's say we return the value of find position of string from 0. If I save that, reload, and I call out main, then I have to enter a string. So if I give it something like, let's do 3, then I get correct format 3, because I didn't put another /n in here. If I call it again, I smash the keyboard, then I'll get incorrect format, empty preload index too large, and that's because it's trying to look through this array and I haven't put in a final case for it. So you can tell that this is not a very good main method, in that it can allow this error to handle because it just happen, just because it does these 5 steps in a row without anything interrupting it. No checks to make sure that it is an appropriate value. So let's try and fix this. So what I want to do is condition this on whether or not a value is in this array. So I'm going to use an if statement. Now, if statements can be a little bit tricky in I/O. We'll see some of their more unique properties as we go along. In input output, we'll see a lot more lets, a lot more ifs, and a lot more cases. So we know all those tools, but we'll see more practice as we go along. It can be a little bit tricky, but we'll figure it out as we go. So I want to say, just borrowing this little piece of logic up here, is if string is an element of nums. So if you can find it in the array, then do something. What I would normally say is I would indent this. And in the then condition, I need to do some more monadic stuff. I need to do some printing. So let's do put string. Oh, that shouldn't be a capital P. God, I can't type. And we're just going to put in a little bit of chat to let the user know that it's valid input. And then I'm going to do the same again, put car, do /n, and then I'm going to return the value of find position of string starting from 0. So that's our then condition. Now I need to wrap this in a do because this whole if statement is wrapped in the do, but the actual evaluation of the then and else conditions are not wrapped in a do. So this is fine because this is just checking a Boolean value, but if I want to do something monadic in here, I need a do statement to make that happen. So something else that's also worth pointing out is in Haskell you can't have an if then. You need an if then else. It's seen as one whole expression, and if you try and just supply it with a then condition and no else, you'll get an error from Haskell. Something else that you need to be worried about is these are seen as one expression, so they should return the same type. So if your then returns a certain type of value, your else also has to do that. So we do the same, str invalid input, and if I just do put car again of /n, and I return value of -1. So if I save this, reload into Haskell, and I carry out main again, and let's do one that's a little bit different. Let's do 8. Oh, actually that's because I missed the keyboard, messed up the keys. So if I do 8, then I get valid input in 8, and you can see the value, the case where I put an incorrect input. So here, this then condition is allowing me to evaluate on the fly in the main method, whereas you could define this via functions if you wanted to, and then just call the function. However, this just is exposing what's happening within the main method. We could carry on over here if we wanted to. We could keep doing more things. There's something a little bit odd with Haskell return statements in that that's not necessarily the end of returning a value, as it is in some other cases. But if you try to put something down here, like a put string or something like that, it would overwrite the returned value, so you wouldn't actually see that as output. So you need to be careful of that. I can also show you, if we do get rid of this do statement up here and just try to carry out these these actions, I get an error condition here because it's could not match type car to IO with actual type, so it's getting upset at me because I don't have this wrapped in a do condition. Similarly, if I tried to return a string here, if I save this and I reload, then you'll see that it gives me the type error of couldn't match type car with int. That's because this has already been defined up here, so it doesn't understand why you would return different things. So if I come back here, so that's the basics of input output. That's how you write a basic main method. You can see it's nothing too wild. You can call functions from within a main method very easily, so you can use them to handle a lot of the legwork for you. You can make your main methods a lot shorter by condensing some of the logic down into functions that you define out with it, and then calling them from within. The main thing to be worried about is just making sure you understand this do notation when you need to wrap things in do's. We'll also see as we go along when you need to use lets or cases, things like that. But that's everything for today. I hope you found this useful. If you have any questions about it, please do let me know. Thanks.